Hello, this is Group 3's presentation. Our topic is regression testing. Our group is composed by Alexander Burov, Christian Longhurst, Daniel Rasmussen, Jarek Johnson, Jose Paredes, and Lucas Bittencourt.
Regression testing is the process of testing the software project based on previous tests you've already completed. SoftwareTestingHelp.com stated to make sure the product works fine with new functionality, bug fixes, or any change in the existing feature. This allows software developer teams to make sure that when they are adding new features, previous features aren't negated or destroyed. This testing model is initiated whenever a developer adds or changes the software, especially new features. This method is usually run manually to make sure that the results are exactly what you expect. Since AI may not have exactly what the results you want or expect, but because of increasing AI, Rosero stated in recent years regarding the study of efficient fault detection ability on regression testings with AI approaches has increased. How to do it? You simply just rerun tests you've already completed. That you make sure you know that they have already given correct results, and you rerun them after the new software.
Retest All method is one of the conventional methods for regression testing, in which all the tests in the existing test suites are rerun. So the Retest All technique is very expensive as compared to techniques which will be discussed further. Thankfully, testers are not the developers, so there are methods to run subsets of tests while the development process goes on. This can make Retest All technique less expensive. Regression testing can be grouped into progressive regression testing and corrective regression testing, depending on whether the specification is changed or not, respectively. In corrective regression testing, the specification doesn't change, only some instructions of the program and possibly some design decisions are modified. This has important implications because most test cases in the previous test plan are likely to be valid. However, the test cases covering the modified parts are no longer valid. The corrective testing can be done after each minor modification. The progressive regression testing involves a modified specification. Whenever new enhancements or new data requirements are incorporated in a system, the specification will be modified. In most cases, new modules will be added to the software, requiring testing. The progressive testing process involves testing a modified program against a modified specification.
So this is Lucas Bittencourt, and I'll be covering both regression test selection and test case prioritization. So for the technique of regression test selection, it may not be productive to keep running every single possible test suite, since tests can take a very long time or be large in number. The idea of regression test selection is to create a selection of which test suites are most relevant to the project. This can be done through algorithms to meet some parameters, such as inclusiveness, precision, efficiency, and generality. So these algorithms can take form for example, in random selection of test suites, or for example, choosing like tests that cover at least every single method that was modified during the process. And for these parameters, inclusiveness analyzes and captures the faults caused as a result of modifications. Precision, those test cases are not selected that won't produce different output than the original one. Efficiency, calculates the cost of computing and practicality of adopting a technique. And generality, ability of a technique to handle complex changes in the system. So when you use the regression test selection, usually tests will fall into two different categories. So we'll have reusable test cases, which are relevant and can be used in succeeding regression cycles. And then we'll get obsolete test cases. These cannot be used in succeeding cycles. So they will be discarded and will not be run again. Another technique of regression testing is test case prioritization. It can be defined as techniques that schedule test cases in an execution order according to some criteria. And these techniques are usually heuristics because the number of execution orders can go extremely high depending on how many test cases are there. So it's usually wise to set for the most efficient solution instead of the optimal one. Doing test case prioritization increases the likelihood that if the test cases are used for regression testing in a given order, they will more closely meet some of the objectives than they would if they were executed in some other order. The objective of testing must be aligned with which points are the most important for the testers. Revealing faults earlier, detecting high-risk faults, revealing regression errors, and so on. Prioritizing critical functionalities will reduce the regression test suite. And when we reduce this regression test suite, uh, we get much better results and in much less time.
Hello, my name is Daniel Rasmussen, and I will be talking about the pros of regression testing. The first pro is thorough symptom coverage. By using regression testing, every single bug or defect can be detected. This extensive debugging can be done if regression testing is performed for every little change that has been introduced into the software. Another benefit is that regression testing requires and therefore produces thorough documentation. The reason for this is that those documents will become the primary source of communication between the development team and quality assurance team about critical product details, like what the problem found in testing was and what measures are being taken to find a solution to these bugs. Thirdly, regression testing builds team confidence. By consistently testing and fixing bugs in updated software, the team is rewarded with affirmative feedback and builds confidence in the software itself. With regression testing, there are ways and methods in which one can automate the testing process, as regression tests are naturally good candidates for automation. Regression testing can also save the company a lot of money by automating tasks that normally would have to be done by employees.
While regression testing is a great tool for maintaining quality of the project after changes are made, it has some issues that make it hard to use as well. The first problem lies with the frequency of tests needed. The problem with regression test is that it is used whenever a change or modification is made to the code, whether it be during or after development. The need to retest the parts of the program affected by the changes can have a toll on resources if changes are frequent or numerous. Issue is that regression testing can be very time consuming and repetitive. Many projects will develop tests to check a specific part of the function. As more is added and developed to the program, then more tests are made. To conduct these tests manually would be time consuming and expensive, especially if these tests must be conducted frequently. So, due to that issue, automatic testing tools have been developed to resolve that problem. But even using automation has its own limits in that they may not catch all the bugs that could be found with manual testing. As time goes on, the project may require more, newer, or bigger tests due to the changes, whether they be functional or specification changes. It requires more tests to be developed. Even the old tests that were made may need to be modified or replaced based on the scope of the modifications. Some of the new tests may need to encompass more features, making them bigger and therefore consume more resources.
Thank you so much for watching our presentation. We hope that you were able to understand what is regression testing, what are the types of regression testing there are, and which are the pros and cons of doing regression testing. Thank you very much.